have, when there's x squared and y squared, we're going to have an ellipse or a hyperbola. With subtracting, it's a hyperbola. So for the x-axis, we're going to take the square root of this, so plus or minus 2. And in the y direction, take the square root of this, it's plus or minus 3. And then if you find the four corners where those meet, that will actually give you the asymptotes. And then, because the x is positive in this equation, the x squared term is positive, then that means it's on the x-axis, so it's going to hit right here, which is actually one of the vertices, and then go out to the asymptotes, and we'll hit right here, which is the other vertex. So we've got the vertices. They are at positive or negative 2 and 0. We can find the equation for the asymptotes because this is a line that goes through the origin, so that means that it's just y equals mx. There is no plus b. And you can find the slope because you go over by 2 and then up by 3. So that means it's a rise of 3, a run of 2, so the asymptotes are going to be y equals a rise of 3, a run of 2 times x. And then this one is going to be the same numbers except negative slope. So you can just then say plus or minus. And then for the focus points. So the focus points would be inside this branch there's going to be 1, and inside this branch there's going to be 1. And these numbers here are called a squared and b squared. Or in other words, this is a and b, so a squared and b squared. And then we could use the formula that for a hyperbola, c squared, which is where this is, a length of c from the center, c squared equals a squared plus b squared. So I always just remember that if this is minus, then in this formula, it's the opposite. If we were talking about an ellipse and this had plus, then this would be the opposite, a squared minus b squared. So we would have that c squared is equal to the 4 plus the 9. So that's going to be that c is the square root of 13. So that's where the focus points are going to be. Plus or minus the square root of 13, comma 0.